Welcome to AI in Real World. This is part 1 of a 3-part video series. In this series, we're going to build an AI-powered weather agent. By the end of this series, you will have an AI weather agent with user interface and voice interaction. You'll be able to ask the agent, "Do I need an umbrella in Seattle tomorrow?" and get AI-driven responses. Why do you need AI to check the weather? Because it's 2025 and everything has to be AI. In this first video, we'll focus on building a simple AI weather agent using n8n, a powerful workflow automation platform. We'll show you how to easily run n8n locally using Docker. This will allow you to quickly test and prototype your AI applications. Specifically, you will learn how to set up n8n locally using Docker Compose. Import and configure a pre-built weather agent workflow. Connect your workflow to external weather APIs and use AI to interpret natural language weather queries. In the second video, we'll turn our weather agent into a fully functional chatbot using an agent framework named Pydantic AI, adding forecasting abilities and better structure to our agent. In the third and last video of the series, we'll add UI and voice capability to our weather agent. You'll be able to speak to our agent and agent will respond to you back. Do I need an umbrella in Seattle tomorrow?
Yes, you might need an umbrella tomorrow in Seattle as there is a forecast of drizzle and cloudy weather during parts of the day with temperatures around 8 to 9 degrees Celsius.
Sounds interesting. Let's get started. Now, this AI agent can predict rain, but it can't predict how much money you're leaving on the table by not using AI in your business. If you're a business owner looking to automate workflows or enhance your applications with AI, book a free consultation with us. Let's make your business forecast as bright as a clear summer day. Link is in the description. Now, back to building this weather agent. First, what is n8n? n8n is an open source, no-code, low-code workflow automation tool. It lets you visually connect different applications and services to create complex workflows. This makes it great for both technical and non-technical users and allow you to easily integrate AI services. n8n is similar to commercial automation solutions like Zapier or Make, but with key differences. n8n is open source, offering self-hosting and customizations, while Zapier and Make are proprietary. n8n is free to self-host with no usage limits, unlike Zapier and Make's subscription pricing. I'm going to show you how to run n8n locally. This offers data privacy, keeping sensitive information within your infrastructure. Local deployment uses local resources for faster workflows, gives you full control for tailored configurations, and eliminates cloud subscription fees, making it an excellent choice for prototyping. Alright, before we dive in, let's take a quick look at the overall architecture of our agent. The process starts with user input, a question about the weather. This input is then sent to our AI agent, which uses its reasoning capabilities to decide which tool to use, like the Weather API or the Location API. The appropriate API is called, and the resulting data is used to generate a final response for the user. Before we start using AI to build this weather agent, let's first answer the question, why use AI for a weather agent in the very first place? Think about a traditional weather application. If you want to ask, do I need a jacket in Chicago tomorrow, you would need a lot of complex code to understand the intent, extract the location, fetch the weather data, and then determine if a jacket is needed based on the specific temperature ranges, right? That involves a lot of if-else statements and natural language processing. With AI, it becomes much simpler. You provide the AI model with necessary tools like the Weather API and the Location API, and it handles the reasoning and decision making for you. When we look at the demo, we'll show you the path the AI takes to get to the answer. First, let's get n8n running locally. We'll use Docker Compose to set up n8n with a Postgres database for persistent data storage. This is the easiest way to get started. But why Docker? Docker allows us to package n8n and its dependencies into a container, ensuring consistent behavior across different environments. It simplifies setup, provides isolation that is preventing conflicts with other software, and makes it easy to move our application between different machines. If you don't have Docker Desktop in your system, just go to docker.com and download Docker Desktop. Once you have installed Docker, it is now time to create containers that run n8n locally. Here's the docker compose.yaml file we'll be using to create n8n. This entire project that you see right here is in Git, and the link to the Git is in the description. So let's walk through this YAML file. First, we define the DB service, which uses a Postgres image. We set the necessary environment variables for the database user, password, and the database name. We also define a volume n8n DB data to persist the database data, ensuring that your data is preserved even if the container is stopped or removed. Next, we define the n8n service. This uses the official n8n Docker image. We'll expose port 5678 for the n8n UI. We set the environment variables to configure n8n to use the Postgres database. Crucially, the DB Postgres DB host is set to DB, which is the name of the database service within the Docker network. This tells n8n to connect to the database container. We'll also enable basic authentication and set the username and password. Finally, we define the volumes for both n8n and the database to ensure persistent storage. Before we start the containers, we need to create a .env file. The docker compose.yaml file references the environment variables defined in this file. And make sure you have these 4 entries. Remember to replace your Postgres user, your Postgres password, your n8n user and the n8n password with your own credential and rename this file to .env. Just an important point to note, never commit the .env file to your source control. That's how you would end up starring in a how not to use GitHub blog post, because the .env file contains sensitive information. So definitely add .env to your git ignore file so it's never accidentally uploaded. Now, open your terminal, navigate to the directory containing the docker compose.yaml file and run docker compose up-d. This will start the n8n and Postgres containers in the background. The -d flag detaches the containers, allowing them to run without tying up to your terminal. You will see the containers running in the Docker desktop. Here, we'll have options to stop and start the containers. Once the containers are running, you can access the n8n UI in your browser at http localhost port 5678. You'll see a sign-up screen to create credentials to log in. This is the home screen of n8n that you will see once you log in. We can now create our weather agent workflow here. Once you create a workflow in n8n, you can export it into a JSON file, which is what I have done already. You can find the link to this JSON file in the description of this video. In the n8n UI, click the plus create button to create a workflow and then select import from file and select the weather agent n8n JSON file. And here is the workflow. It starts with a when chat message received trigger. This is how we'll send questions to our AI agent. To add a new node, click the plus button and search for the node you intend to add. In our case, we'll search for AI agent. And there you go. Click on this to add the node to the workflow. This is the core of our AI agent. For the type of the agent, we select Tools Agent, as we'll use a couple of external tools to help agent perform necessary tasks. And for the system prompt, we keep it simple and say be concise, reply with one sentence, always include temperature in your response. The AI agent is connected to the large language model, memory, and 2 tools. Let's look at them one by one. OpenAI chat model. Our AI agent node used this node to interface with the OpenAI API to generate response from the LLM. We are using the model GPT-4o Mini. Remember to configure the OpenAI credentials and enter your Open API key. Remember to keep the API keys secure and never commit them to version control. The getLat_lang node uses an HTTP request tool to get the latitude and longitude of a location from GeoMaps API. It takes 2 parameters. First, the location description, and second, an API key. You'll need to sign up for a free account and replace the API key with your own. Now, the getWeather node. This node uses a HTTP request tool again to get the weather from tomorrow.io API with latitude and longitude as input. You'll need to sign up for a free account and replace the API key with your own. Next, we got window buffer memory. This node provides memory to the AI agent, allowing it to remember previous interactions. It uses a window to store recent conversations, which helps the agent understand context. For example, if your first question is, what is the weather in Chicago, followed by, do I need a jacket tomorrow? With the history, AI can understand that we are referring to the location Chicago in the second question. The AI agent is configured to use all these tools to answer questions about the weather. Now let's test the agent. I'm going to click chat and let's type the question, what is the temperature in Chicago? And you can see the AI agent responded with the current temperature in Chicago. Now let's examine the flow of events. For the question, what is the temperature in Chicago? The agent infers the location that we are interested in is in Chicago. And first, uses the get lat lang tool to get the coordinates of Chicago. Then it uses the get weather tool to get the weather data. And finally, it generated a response. And the AI agent used the OpenAI LLM all along. Now let's ask, do I need a jacket? And here we have a response. Our agent says, yes, with a temperature of 9.5 degrees Celsius, you should consider wearing a jacket. Now, if you look at the flow of events, our AI agent used the window buffer memory to understand we are talking about Chicago. And it also knows the temperature in Chicago is 9.5 degrees Celsius. With that information, it was able to suggest to us that we need a jacket. Alright, in this video, we built a simple AI weather agent using n8n. We learned how to set up n8n locally using Docker and import a pre-built workflow and connect the workflow with external weather APIs and built a decent AI weather agent. In the next video, we'll take this agent and turn it into a more interactive chatbot using the agentic framework Pydantic AI. And we'll also add forecasting abilities to our agent. In the third video of this series, we're going to turn our agent into a voice agent, adding UI and voice. So don't forget to subscribe to the channel and hit the notification bell to get notified of our future videos. And book a free AI consultation call with us if you need help integrating AI into your business. We can help you identify the best use cases and build custom AI solutions. The link is in the description below, and thanks for watching.